Hello students, welcome to course on differential equations of first order. Now in this video, we are going to see how to solve linear differential equation. Now basically standard form of linear equation is dy by dx plus p into y, which is equal to q, where p and q are functions of x. Now if you observe the degree of dependent variable, that is y, and its differential term, what is degree of this is 1. So when degree of dependent variable and its differential term, what is degree? It is 1. So when the degree is 1, such type of equations are called as linear differential equations. This is the definition. Okay, so a differential equation is said to be linear if dependent variable and its differential coefficient is of first degree. That means degree is what? 1. Okay, now such type of equation is called as Leibniz linear equation. Okay, so Leibniz is also one scientist based on whom the name to the linear equation is given. Okay, so what is the Leibniz linear equation? It is dy by dx plus p into y, which is equal to q. P and y, these are functions of x. These are functions of x. Now suppose, let's say you want to solve this equation. Okay, now how we are going to solve Leibniz linear equation? Let us see that. So we have to solve dy by dx plus p into y, which is equal to q. Now what I will do, I am multiplying both side by factor e to the power integration p into dx. Okay, so what I will get? I will get dy by dx into e to the power integration of p dx plus p into y into e to the power p into dx, which is equal to q into e to the power integration of p dx. Now, if you observe LHS, LHS is nothing but it is a d by dx of y into e to the power integration of p dx. Okay, so y into derivative of this plus this term, that is second term into derivative of first. Okay, you can check it out, which is equal to q into e to the power p into dx. Okay, now on integrating both sides, if you integrate on integrating both sides, what I will get? What will be integration of LHS? It will be y into e to the power integration of p dx, which is equal to integration of q into e to the power integration of p dx into dx plus constant c. Okay, so this will be required solution. This will be required solution of Leibniz linear equation. Now, if I am calling e to the power, suppose I am calling e to the power integration of p dx as integrating factor. I am considering it as what? Integrating factor, which is also abbreviated as IF. So I can write this equation as y into, can I write integrating factor? Yes, which is equal to integration of q into integrating factor into dx plus c. So this is how you have to remember the solution. Okay, is it clear to everyone? What is that? Y into integrating factor, which is equal to integration of q into integrating factor into dx plus c. This is the solution, right? This is very important. Number of times you will find a question in university exam. It is very common, as well as in GATE, ESE and other competitive exam. So you have to remember this solution. Okay, so basically you have to remember the two things. One is what is the form, and second what is its solution. Okay, now let us solve one numerical on this. Let us solve one question so that you will come to know how we can find the solution for Leibniz equation. Now the question says solve x plus 1 into dy by dx minus y, which is equal to e to the power 3x in bracket x plus 1 bracket square. Okay, so you have to find the solution for this differential equation, which is of first order, right? Okay, now we will try to put this in which form? In Leibniz form, that is dy by dx plus p into y, which is equal to q, where p and q are what? Functions of x. So we will try to put the given problem in this format. So I will divide the whole equation with x plus 1. Dividing by x plus 1, I will get dy by dx minus y into x plus 1, which is equal to e to the power 3x. What I will get here? X plus 1. Is it right? Now, if you compare this with our Leibniz form, this is nothing but Leibniz equation. So if you compare this with our standard format, dy by dx plus p into y, which is equal to q. So I will get what? What I will get? I will get p is equal to minus 1 upon 1 plus x, right? Therefore, what will be integration of p into dx? See, basically, we have to find out integrating factor. What is integrating factor? E to the power integration of p dx. So we will find one by one. What is integration of p into dx? Integration of dx upon 1 plus x minus. This is equal to minus log of 1 plus x, which is equal to log of 1 plus x to the power minus 1. Right? Therefore, we can write integrating factor, which is equal to e to the power integration of p dx, which is equal to e to the power, what is this integration? Log of 1 plus x to the power minus 1. Okay, now e to the power log. Okay, it will be what? It will be 1 plus x to the power minus 1. So what I will get here? I will get this is at 1 plus x. Okay, is this correct? Okay, so solution, therefore, what is the format of solution? What is the solution? Y into integrating factor, which is equal to integration of q into if into dx plus this is solution, right? So our solution will be y into integrating factor. What is integrating factor? 1 upon 1 plus x, which is equal to integration of q. What is q here? What is q here? This is our q, right? So q, I will write the q into x plus 1 into integrating factor 1 plus x into dx plus c. So y upon 1 plus x, which is equal to, see this term, it will get cancelled out. What will be integration of e to the power 3x into dx? It will be e to the power 3x into 1 by 3 plus c. Okay, so what we can write? We can write y is equal to 1 upon 3 into e to the power 3x plus c into 1 plus x. So this will be your answer. This will be the solution to the given differential equation of first order. Okay, so hope with this the method to find the solution to the linear equation is clear. Okay, so quickly we will revise it. What are linear equation? These are the equations in which dependent variable and its differential coefficients are of degree 1. What is the standard form of Leibniz linear equation? It is dy by dx plus py, which is equal to q, where p and q are functions of x. Okay, and what is the solution to the Leibniz equation? It is y into integrating factor, which is equal to integration of q into integrating factor dx plus c. And what is this integrating factor? The integrating factor is what? It is e to the power integration of p into dx. Right? So hope this method is clear to everyone. Thank you.